and wild. The Pennines around Sheffield offer some of the most dramatic scenery in Yorkshire. For generations, the stark beauty of the hills has remained largely unchanged. Millstone grit country like this is the very heart of upland Yorkshire. It's a land of strength and tradition, and one of its main strengths is an industry which has earned both recognition and respect throughout the world. An industry which is as much a part of life as the hills themselves. We're talking, of course, about steel. Stocksbridge Engineering Steels is the specialist division of United Engineering Steels, Europe's leading producer of steels for engineering applications. Here, in Sheffield's biggest steelworks, high performance and speciality steels have been produced for over 50 years. But steel manufacturing in the Stocksbridge Valley goes back much further than that. In fact, as far back as 1842, when Samuel Fox set up a wire drawing business to supply the wool textile industry. In the years which followed, production diversified, and in 1852, Fox patented the Paragon umbrella frame, a design which formed the basis of all folding umbrellas. Another novel use for his steel wire was in the production of support cages, used to help ladies' crinoline dresses keep their shape. The introduction of Bessemer steelmaking at Stocksbridge in 1862 marked the start of a long association between the valley's industry and transport-oriented products. In the early days, steel rails and rolling stock components such as tires, axles and wheels were the mainstay of the business, although light products like wire, springs and umbrella frames continued to be manufactured. In 1918, the works gave up Bessemer steelmaking and from 1930 began concentrating on the production of alloy, special and stainless steels, many of which were marketed under the world-famous Fox brand name. Throughout the years, this course has been maintained, and as a result, Stocksbridge has long occupied a key position in the United Kingdom's production of specialist steels. Firstly, as part of United Steel Companies, and later as part of the British Steel Corporation. In 1986, British Steel Corporation's Special Steels Division merged with GKN's Brimbo Steelworks and Forgings Division. The result was the formation of United Engineering Steels Limited, of which Stocksbridge became the specialist steelmaking division. Throughout all the changes, though, the function of Stocksbridge has remained essentially unchanged. The production of high-integrity alloy and stainless steel for high-tech applications. So, although the name Stocksbridge Engineering Steels may be a new one in the world of steel, its roots go back to the very birth of the industry. And today, the company benefits from well over a century of steel-making experience and know-how. Indeed, it can truly be claimed that Stocksbridge Steel is at the very heart of many of today's most demanding industries. Applications which include automotive, agricultural and earth-moving equipment, aerospace and defense, energy industries, including oil and gas exploration and production, mining and electricity generation, and specialist engineering applications such as bearings and gas cylinders. Although the basic principles of making steel have remained largely unchanged, the technology involved has come a long way since the days of Samuel Fox. At Stocksbridge, the process begins in the raw materials stockyard, where specially selected steel scrap from a wide range of sources is gathered together before being melted down. Day and night, cress carriers move scrap to the melting shop, where powerful electromagnets load it into large steel baskets ready to be charged into the furnace. A modern electric arc furnace consists of a circular vessel lined with heat-resisting bricks and water-cooled panels and fitted with a movable lid through which 3 carbon electrodes can be raised or lowered. When the furnace is ready, the electrodes are lifted, allowing the lid to be swung clear, and scrap is charged from the basket. A large electric arc furnace can melt up to 150 tons of steel. It takes 2 to 2.5 hours to produce this amount and consumes 2 or 3 baskets of scrap. When the furnace is fully charged and the lid has been swung back into place, the electrodes are lowered and a powerful electric current is passed through them. The resulting arc, which is struck, generates an intense heat which melts the scrap. Temperatures inside the furnace can reach over 1500 degrees centigrade. Lime, fluorspar and other materials are added to the bath of molten metal. These combine with any remaining impurities to form a liquid slag on the surface, which is removed during the process. Free from slag, the steel is tapped into a refractory-lined steel ladle, ready for transfer to a secondary steel-making unit for further processing. At this point, the final alloying additions are made to obtain the required composition, and the melt temperature is optimized. Purging also takes place to ensure high cleanness levels in the steels produced. The traditional means of dealing with liquid steel is to convert it into solid pieces called ingots. To do this, the molten metal is taken in a ladle to a teaming stage, where it is poured or teamed into molds. The stream of liquid steel goes down a central funnel and feeds a cluster of molds from the bottom. This method of casting is known as uphill teaming and produces cleaner ingots with a much better surface finish. Additives are used at the start and finish of teaming to ensure that sound ingots are produced consistently. Ingots are transferred to the billet mill for rolling to a variety of sections, such as squares, rounds, or slabs. Before they can be rolled, the ingots need to be reheated, and this is done in a fuel-fired soaking pit. The whole soaking process is controlled by computer to ensure the steel reaches exactly the right metallurgical condition for rolling with minimum energy consumption. It takes up to 10 hours to reheat ingots to rolling temperature, and in normal production, one is fed to the mill every 2 minutes. In the billet mill, primary rolling reduces ingots to an intermediate size by passing the steel back and forth through progressively smaller gaps. The surface quality of many grades of steel is improved by removing a small layer of material on an inline scarfing machine. Once it has been scarfed, the rolled steel is trimmed at both ends before passing for further rolling. Finally, it is cut to length, identified, and transferred to the cooling beds. The final production stages take place in billet finishing. Here, the steel, now in the form of billets, blooms, slabs, or rounds, goes through several processes depending on its intended use. For certain grades, the required strength and hardness is achieved by reheating the steel in annealing furnaces. This is followed by quenching in oil or water, or by controlled cooling. Round bars can be precision turned or ground to the exact size as ordered by the customer. And bars with a bright finish can be given a protective plastic wrapping to preserve their finish during delivery. Throughout the whole process, the accent is on ensuring that only steel of the highest quality is sent to customers. Minute surface defects are pinpointed by a thermomatic inspection system utilizing sophisticated infrared techniques, while internal structures are thoroughly checked by the latest ultrasonic technology. In recent years, another method of converting liquid steel continuously to solid product has been developed, in which there is no need to cast intermediate ingots. Liquid steel for continuous casting is teamed into a tundish from which it flows down 4 outlet nozzles into water-cooled molds. As it solidifies, the steel is withdrawn from the molds and is cut to length. The cast billets are then transferred to cooling beds. The Stocksbridge continuous caster is a vertical machine and was installed at a cost of £26 million in 1982. It incorporates several computer-controlled, state-of-the-art features to ensure high-quality output, and produces rounds and square billets in a number of sizes. Continuously cast steel needs little further processing before being dispatched to the customer, and Stocksbridge concast steels are widely used in tube making. One of the most important and demanding market sectors is aerospace and defense. Steel for these applications needs to be produced to the highest possible standards of cleanness. Many of the requirements can only be met by remelting the original steel ingots under carefully controlled conditions before they are ready for rolling. Stocksbridge operates a remelted steels department which produces both ESR, electro-slag refined, and VAR, vacuum arc remelted ingots for this demanding market. During remelting, an electric arc is struck between the furnace base plate and the ingot, which is treated as an electrode. As a result, the ingot melts progressively along its length from bottom to top, producing a new refined ingot which is then sent to the billet mill for rolling in the normal manner. The department's ESR and VAR furnaces all incorporate the very latest computer-controlled systems, enabling the highest and most consistent product quality to be achieved competitively. Special dedicated finishing facilities are employed on remelted products, including immersion ultrasonics, which confirm the absence of even the most minute internal defects. Product quality and developments of this sort, for which Stocksbridge is justly renowned, can only be achieved with the support of a dedicated professional backup team. Technical personnel are involved at all stages of monitoring, product testing and customer liaison. In addition, ongoing close links are maintained with Swindon Laboratories, a world-famous specialist steel research unit based in South Yorkshire. Such is the Stocksbridge commitment to product excellence and the needs of the market that millions of pounds have been invested in recent years, much of it in new plant and technology dedicated to improving and advancing steelmaking and its subsequent processing. But the greatest asset of any successful business is a trained and motivated workforce. To ensure continuity in this important aspect of the company's activities, selected recruitment takes place both at university and school leaver level.
Yeah, that's no problem.
Newcomers to the industry receive appropriate training in a purpose-built training centre and on a variety of placements in different departments. A recent project completed by craft trainees was the fabrication of stainless steel funnel badges for HMS Sheffield, a Royal Navy Type 22 frigate commissioned in 1988. For the company, the badges were a particularly appropriate finishing touch, since Stocksbridge steels perform many vital roles in the vessel, being incorporated in her Rolls-Royce gas turbine propulsion units and her Lynx helicopters. As Sheffield's largest steelworks, Stocksbridge is proud to contribute its technology to this fine vessel. Generally, the company contributes the region's cultural traditions through its brass band, which is fast establishing itself among the best of brass, despite its steel roots. Any plant producing 500,000 tons of liquid steel a year is bound to have some effect on its surroundings. But Stocksbridge is always mindful of its responsibilities to the local community. Several schemes, some of which are ongoing, have been implemented in recent years to improve the quality of the valley's environment. Now, at a time when the future of the countryside is becoming of increasing public concern, the company has already embarked on a major landscaping scheme with help from the Countryside Commission. The scheme also has the support of Stocksbridge Town Council and Sheffield City Council and is bringing wide-ranging environmental improvements to more than 40 acres of land surrounding the steelworks. It includes the planting of over 100,000 trees and, through the efforts of a full-time woodlands officer, is involving the local community, especially school children.
Hello, it's Jane Jordan. Can I help you?
The Stocksbridge philosophy of care and responsibility is also applied with equal importance to each of its customers and to every order it receives. Extensive use of computer systems and information technology is applied throughout the whole organization, from order entry through production, order progress, quality control, dispatch and delivery. process is controlled, monitored and coordinated to ensure that only the finest quality product reaches the customer precisely when he wants it, and with all necessary certificates of quality and technical documentation. Such commitment to excellence, pushing forward the boundaries of steel-making technology in the constant search for even higher standards, has earned Stocksbridge Engineering Steels an enviable reputation around the globe. These are just a few of the many companies which approve Stocksbridge quality steels for use in their products. These are some of the world's greatest names in engineering, companies which trust their reputation to the advanced technology and expertise of one of the world's leading makers of special steels. These are companies which recognize that Stocksbridge Engineering Steels really is the strength behind engineering progress.